All right, this is 4.4. Our objectives for today are the student will be able to factor polynomials and use the factor theorem. Factoring we've already done, the X method, different things, but this is a review of it and some extra factoring steps we can do in factoring. So remember, when we factor, the first thing we want to do is check for the greatest common factor and then use the X method. So if we were, as an example, to do x cubed minus 4x squared minus 5x, and we were supposed to factor that. So the first thing we do is check for the greatest common factor. There's no number that goes into all those other than 1, which doesn't help us, but there is an x in front of each of those, in each one. So I'm going to pull an x out, and then I get x squared minus 4x minus 5. And then we should try and factor what's left. So if we did the X method, that would be negative 5 times 1 is negative 5, because remember that's A times C, and this is B. And our B is negative 4, so that would be negative 5 and 1. Remember, since the first term is 1, we don't have to build the box. So this, we still have the X, but the rest of this factors in into X minus 5 and X plus 1. Now remember, if that's not a 1, then we have to build the box. But that would be factored completely then. So that was factoring on that one. Let's take another one. Do 3y to the 5th minus 48y to the 3rd. So 3 goes into both these, so I can pull a 3 out. Then we have 5y's here and 3y's there, so we can pull out 3y's as the greatest common factor. And so to get from here to here, we need a y squared, and 3 goes into 48 16 times, and we have our y to the 3rd, so it's there. Now, it's nice if you can recognize, if you remember, the difference of two squares, a squared minus b squared. If it's in that form, remember, factors into a plus b and a minus b, so you just take the square root of both. So we keep the 3y to the 3rd, and then this would be y plus 4 and y minus 4. That's a shortcut. If you can't remember that, we can still do the X method. Negative 16 times 1 is negative 16. There is no middle term, so that's 0. So the numbers that multiply together to give you negative 16 and add up to give you 0 are 4 and negative 4. It's a 1, so we can, it's y plus 4 and y minus 4. So you can always build the box when you get down to that y squared. But if you can remember the shortcut, it's a little bit easier. Let's try one other one. 5z to the 4th plus 30z to the 3rd plus 45z squared. So again, we check for greatest common factor. 5 goes into all those, so we can pull the 5 out. We have 4 z's, 3 z's, and 2 z's, so they all have at least 2 z's, so I can pull that out. To get back to this, we need a z squared. 5 to get to 30, we need a 6. Z squared to get to z, we need a z. And 5 to get to 45, we need a 9. And we have the z squared. Again, this is one of the shortcuts. If we can recognize that it's in the form of a squared plus 2ab plus b squared, that factors into a plus b squared. So in this case, that's when I take the square root of a squared is a, the square root of b squared is b. So the square root of z squared is z, the square root of 9 is 3. And if you multiply those together and double it, and you get the middle term, which we would, so I can factor that into z plus 3 squared. Again, that's a shortcut. If you want to do the X method, it still works. 9 and 6, so that would be 3 and 3. So z plus 3 and z plus 3. So I don't care if you write it this way or this way. They're both correct. Again, this is a shortcut, but most of you are probably just as fast using the X method. So I'd like you to try some now. So I'd like you to try these 3 problems. First one, x cubed minus 7x squared plus 10x. The second one, 3n to the 7th minus 75n to the 5th. And the third one, 8m to the 5th minus 16m to the 4th plus 8m to the 3rd. So again, pause the video here, try all three of these, and then come back and I'll go through them so you can see if they're right. So if we did the first one, again, we check for greatest common factor. I can pull an x out. So this is number 1. Pull an x out, and I get x squared minus 7x plus 10. We can do the x method. That would be 10 and negative 7. So negative 5 and negative 2. So that would be x and x minus 5 and x minus 2. So hopefully you got that one. The second one, 3n to the 7th minus 75n to the 5th. So hopefully you recognize that 3 goes into both those. And we have 7 n's and 5 n's, so I can pull out 5 n's. And so we get n squared minus 25. And again, whether you recognize the shortcut or you go ahead and do the x method, the shortcut would be n plus 5 and n minus 5. Again, if you do the x method, you have negative 25 and 0, which would be 5 and negative 5. So you get the same answer, should have gotten the same answer either way. And then the last one, 8m to the 5th minus 16m to the 4th plus 8m to the 3rd. We can pull out a 8 and 5, 4, and 3, and 8m to the 3rd. And so we get m squared minus 2m plus 1. So again, this is the perfect square, where this is the square root of this and the square root of this double gives you the middle. So that would be 8m to the 3rd and then m minus 1 squared. Again, if you don't remember that, you do the shortcut. It would be 1 and negative 2, so that would be negative 1 and negative 1. And so you get 8m cubed and then m minus 1 and m minus 1. And you get the same thing both ways, so whichever way works best for you. So again, the big thing here is take out the greatest common factor and then factor using the x method or any of the previous shortcuts that we've had. So next, so 2 other shortcuts we're going to add to your tools. And that is the sum of 2 cubes and the difference of 2 cubes. This is a to the 3rd plus b to the 3rd. It becomes a plus b, where you just take the cubes of both those. The sign is the same. And then a squared minus ab plus b squared. With the difference of 2 cubes, this is a minus. The first one's now a minus. But in the second one, your first sign is a positive, not a negative. So examples of this would be like x cubed minus 125. What you want to recognize is, can I write it as one of these? So it's minus, that's a cube, that's the first clue that it might be, so I can go x cubed. And then I just have to ask myself, is 125 a perfect cube? And it is. I can write that as 5 cubed. So that would become a minus b, so x minus 5. And then a squared, so that in this case our a, so if it helps you, you can put, oh, in this case our a is x and our b is 5. And so a squared would be x squared and then plus ab, so 5x, plus b squared, which is 25, and we're done. Another one, 16s to the 5th plus 54s to the 2nd. So, just like before, the first thing we always want to check for is that greatest common factor. In this case, 2 goes into both, and I have 5 s's and 2 s's, so I can pull out 2 s's. And so 2 to get to 16, I need 8 s to the 3rd plus 27. Now again, That cube is the key. That tells us, let's see if that is a perfect cube. So I can write s, 8, I can go 2s to the third, and I can write 27 as 3 to the third. And so that would equal, again, my 2s squared stays the same. I don't change that, I don't drop it. And now I'm using the sum of two cubes. So my a in this case, my a is 2s, and my b is 3. If it helps you to write that out, by all means do. You don't need to, but a lot of people it helps. So it would be a plus b, so 2s plus 3, and then a squared, so I have to square this whole thing, so that would be 4s squared, and then minus a times b, so 2s times 3 would be 6s, and then plus b squared, and 3 squared is 9, and we're done. So that would be how we could use the sum and difference of two cubes. So let's try one with grouping. Let's go x to the third plus 5x squared minus 4x minus 20. Now, usually you can just group the first two and the last two. There's times where you have to rearrange the order. I don't think you'll see anything on the assignment like this of that type. So if we just group the first two, so we're going to take and group the x cubed plus 5x squared. Now I'll usually put a plus sign there. You don't want to put the minus. You want to keep the negative sign with. If you put it here, you have to change everything. So I'm going to keep everything together. And so now we factor like we normally would. We just factor separately. So I check for greatest common factor. I can pull an x squared out. So x squared to get to x cubed, I need an x. And x squared to get to 5x squared, I need a 5. Here I want this to end up to be the same as this. So I can pull a 4 out of both of these. Since they're both negative, I'm going to pull a negative 4 out. So I get negative 4 to get to negative 4x would just be plus x. And negative 4 to get to 20 would be a plus 5. And so you can see that this factor is the same as this. So now what I'm going to do is the same thing I did here. Here I took an x squared out of both of these. And here I took a negative 4 out of both these. So now I'm going to take these, and what they have in common is this x plus 5. So I can pull the x plus 5 out of both of those. So that comes out front, and then what I'm missing is this x squared minus 4. And so that goes in the next one. So to get from here to here, I need an x squared, and to get from here to there, I need the minus 4. And then what you always have to do is make sure that you factor completely. This x squared minus 4, again, anytime you have an x squared, you should check and see, can I factor that further? In this case, that's the difference of two squares, so that factors into x plus 2, x minus 2. Again, if you can't remember that, you can do the x method. Negative 4 times 1 is a negative 4. There is no middle term, so that's 0. So that's 2 and negative 2. And you can see we get the same thing. So that's if you have more than 3, try and do it by grouping. Another special situation to look at. Okay, so another thing we have to look at is we can sometimes factor polynomials in quadratic form that aren't in quadratic form. So remember, quadratic form would be the highest power is 2. So an example of something like this would be 16x to the 4th minus 81. Now we can only do this when the middle term's degree is half the degree of the polynomial. Now in this case, we don't have a middle term. So we can actually write this 16x to the 4th minus 0x squared minus 81. So anytime there is no middle term, I can always write it as half, so we can use this. And what we do now is we write this as if it was the power of 2. So what I'm going to do is I'm going to change this and rewrite it 4x squared minus, I'm going to write this one as 9 squared. Okay? And then if we remember, we've got the a squared minus b squared. If we can write it in that form, I can factor it into a plus b and a minus b. Okay? So, in this case, my square root of this, my a is 4x squared, and my b is 9, and so I could write this as 4x squared plus 9 and 4x squared minus 9. Okay? Again, you can do the x method to do that, but you get the same thing. It's just, if you can recognize this a squared minus b squared, it's really helpful. But now you should always check to see if you can factor this out any further. And this is a plus sign, so I can't do that. You can't do a binomial if it's plus. But again, if this is minus, I can do it if I can write it in this form. Now again, you can try the x method. If I tried the x method on this first one, that would be 36 and 0. But now I need numbers that multiply together to give you 36 and add it to give you 0. And then they have to be both positive in this case, so there aren't any. But on this one, I can use the x method because I get negative 36 and 0, which would be 6 and negative 6. But again, then you have to build the box. The idea is that we can recognize that this is the perfect square. So it factors into, again, using this, the square root of a squared, that would be 2x plus 3 and 2x minus 3. Again, you can get the same thing if you do the box. You would have, we're doing this 4x squared minus 9, and then 6x and negative 6x. So that would be 2x minus 3 and 2x plus 3. And you get the same thing. But you can only do this if that middle term's degree is half the degree of the polynomial. So let's try another one of those, because that's a lot different than what you've been working with. Let's take 3p to the 8th plus 15p to the 5th plus 18p to the 2nd. So let's take this, we check for greatest common factor. 3 goes into all those, and 8 p's, 5 p's, and 2 p's, they all have at least 2 p's, so I can pull 2 p's out. And so to get from here to here, I need p to the 6th, plus 3 to get to 15 is 5p to the 3rd, because we have 2 p's, we need 5, plus 6, and we have the p squared, so that would just be it. Okay? Now here's the thing. This is half of this. So all I'm going to do is I'm going to rewrite this. This becomes p to the 3rd squared plus 5p to the 3rd plus 6. So I use my x method. The factors of 6 that add up to 5 are 3 and 2. There's a 1 in front. So my final answer is 3p to the 3rd. Excuse me, 3p to the 2nd. That stays the same. And then it would be, the only difference is instead of x squared, it's p to the 3rd plus 2. And p to the 3rd plus 3. Now you can always check this to see if it comes out right. P to the 3rd, p to the 3rd is p to the 6th. This would be 3p to the 3rd and 2p to the 3rd, which is 5p to the 3rd, and plus 6. The only thing I would say here is, because these are cubes, I would check and make sure I don't have the sum or difference of 2 cubes. P to the 3rd is a cube, and p to the 3rd is a cube here, but 2 is not a cube and 3 is not a cube, so I would be done. So you can see these get a little bit tricky once you get into all the things you can use. So what I'd like to do now is have you try some of these, not knowing which one to use, that we can look at all the ones that we have and see if we can factor these out. So as an example, if I took a cubed plus 27. So as I go to look to factor these, So you can try it on your own, then come back and look at it, but I'll go through it. So it's a cube. So I would look and say, does that fit my cube? Remember, we have a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. A is obviously a cube. The question is 27 a cube? Which it is, so that's 3 cubed. So in this case, my a is a, and my b is 3. And so I just plug it in, and it would be a plus 3, and then a squared minus 3a plus 9. And we're done. So hopefully that's what you got. So a second one to try. Six z to the fifth minus 750 z squared. So try that, then come back. So hopefully the first thing you recognized was the greatest common factor. I can pull a 6 z squared out of that. And so that gives me z to the third minus 125. Then again, because it's a cube, we should look at our, see if this is a cube, which it is. So I can write this as z cubed minus 5 cubed. So for our general formula, that would be a is z and b is 5. Remember, this is a cubed minus b cubed, which is a minus b times a squared plus ab plus b squared. So this would factor into, again, the 6z squared stays out front. And then we get a minus b, so z minus 5. Times a squared, so in this case z squared, plus 5z plus 25. And we're done. Next. So next I'd like you to try this one. X cubed plus 4x squared minus x minus 4. So again, pause the video, try it, come back and check it. So this is one where we have more than 4, or 3, we want to group it. So I would try group the 2. Greatest common factor here is an x squared, so I get x squared and then x plus 4. And here I can pull out a negative 1, and so that gives me x plus 4. And so then these both have an x plus 4 in common. So I pull out that x plus 4, and then the x squared minus 1. So some of you may have gotten there. Again, you should always check when it's squared to see if you can factor it further. Again, you can use the x method or the shortcut, which is a squared minus b squared. Factors into a plus b, a minus b. And so this factors, the x plus 4 stays the same. Can't factor that any further. But the x squared minus 1 factors into x plus 1, x minus 1. Again, you could have used the x method. That would be negative 1 and 0, which would be 1 and negative 1. X and negative 1, so you would have gotten that. All right, next. Try this one. 3y cubed plus y squared plus 9y plus 3. Pause the video, try it, come back. Again, if we group this, it was more than 3 terms. I can pull out a y squared, and I get 3y plus 1. Remember, if it's the same, you still need that 1 there. Here I can pull a 3 out, and I get 3y plus 1. Again, this is the real key, that these are the same. So since they're both the same, I can pull a 3y plus 1 out. And then these, what's left, goes inside the next one. Y squared plus 3. It's squared, so we should check this, but there are, again, if you do the x method, there are no factors of 3 that add up to 0. And so you're done. So this would be your answer on that one. That would be factored completely. 2 more I want you to try. 16 n to the 4th plus 625. So here's one a little bit different. Again, it's the 4th power. There is no middle term, so I can say that's 0 and look to factor that. So let's try this one. 16n to the 4th minus 625. So there is no greatest common factor. But again, remember, if that degree in the middle, we can make that whatever we want since it's 0. So I can rewrite this 0n squared minus 625. So that's half. So let's try and see if we can factor that into squares. 625 is 25 squared. So now, this is the difference of 2 squares. A squared minus b squared. A plus b. A minus b. So my a in this case is 4n squared. There should be a square there to get to n to the 4th. And my b is 25, so that factors into 4n squared plus 25 and 4n squared minus 25. Again, it's a squared. We should check it, but it's 2 terms addition. We can't. But this one is 2 terms with a minus. So again, we're back to this. Our a in this case is, I can write that 2n squared to get 4n squared, and then minus 5 squared to get to 25. So the first one stays the same, and the last one becomes 2n plus 5 and 2n minus 5. Again, you can do the x method. That would be a negative 100, and then that would be 0. And so that would be 10 and negative 10, but then you'd have to build the box, so you can see it takes a little bit more work, but you will still get the same answer. So let's do one last one for factoring. Let's take 5w to the 6th minus 25w to the 4th plus 30w squared. So in this case, check for greatest common factor. I can pull a 5 out, and there's 6, 4, and 2, so I can pull w squared out. So I get w to the 4th minus 5w squared plus 6. Now again, this is half of this, so I can do it as a square. I just change, I rewrite it, and that becomes w squared squared minus 5w and squared plus 6. But again, that's half, and so we can do the x method. It's 6 and negative 5, so negative 3 and negative 2. So it simply becomes w, you're just going to have a w squared, and then minus 3, and a w squared minus 2. Now these are 2 terms. Again, we can check it. W to the 4th, yes. Negative 2w squared and negative 3w squared is a negative 5. And negative 3 and negative 2 is a negative 6. These are minus, but I can't use the a squared minus b squared. Even though a would be w, I can't take the square root of 3 or the square root of 2. So I would just be done here. That would be factored all the way. So hopefully you found those fairly easy to do. We have one last thing we're going to cover on this. And that is another core concept, the factor theorem. It says a polynomial f of x has a factor x minus k if this IFF means if and only if. Okay, you might have seen that in geometry. It's if you have a theorem that says if and only if, it just means it works both ways. If x minus k is a factor of the function, then f of k equals 0. Or if f of k equals 0, then x minus k is a factor. You can do either one. So in other words, what this does is if something is a factor of anything, then the remainder is 0. So that tells us we could use synthetic division to determine if x minus k is a factor of the polynomial. So what they're going to ask you to do is things like this. Determine if x minus 2 is a factor of f of x equal x squared plus 2x minus 4. Well, all we have to do is do the synthetic division. So if you remember from 4(3), if we write down the coefficients, 1, 2, negative 4, and then we put the k out opposite that, so 2, bring down the number, 2 times 1 is 2, 2 plus 2 is 4, 2 times 4 is 8. That's my remainder 4. If that's 0, the answer is yes. If it's not 0, then the answer is no. So that doesn't work. Let's try another one. Let's say determine if x plus 5 is a factor of 3x to the 4th plus 15x to the 3rd minus x squared plus 25. So now we do our synthetic, let me write that again, 3x to the 4th plus 15x to the 3rd minus x squared plus 25 would be the whole thing. So again, we write our coefficients, 3, 15, negative 1. Now there's no x, so again, you have to remember to put that 0. 25, and we're going to do opposite this, so negative 5. So we bring down the 3, that would be negative 15, so that would be 0, 0, negative 1, that would be 5. Bring down the 5, negative 5 times 5 is negative 25. So again, we get our remainder is 0. So in this case, that would be yes. It is a factor of that. Okay? And then the other thing they're going to ask us to do on this is the same type of thing, but it'll be worded a little bit differently. It's going to say, show x plus 3 is a factor of x to the 4th plus 3x to the 3rd minus x minus 3. And then factor completely. So that means factor it the rest of the way. So they're telling you it's a factor, they just want you to show it. So here's what you do on this. So we write down our coefficients, 1, 3, again there is no x squared, so we have to remember that's 0. Negative 1, negative 3. Put our symbol. This would be negative 3, opposite what it says. 1, multiply, negative 3, add, 0, 0, 0, 0, negative 1, positive 3. So we've shown that it's a factor. Now they want us to factor what's left. Well, remember, remainder, constant. So there is no x squared, but there is an x cubed. So they want us now to factor that. Well, that's our difference of cubes, right? That factors into a minus b, and then a squared plus ab plus b squared. And so in this case, our a is x, and our b is 1. And so we had x plus 3 as a factor. We were told that, we proved it. And then we got down to this so we could factor what was left. So we had this, x cubed minus 1, but we have to factor it completely. And so that would be x minus 1, and then x squared plus x, because 1 times x is x, plus b squared, which is 1. And so that would be factored completely. So let's have you guys try this. So again, the one type they're going to do is determine if x minus 4 is a factor of f of x equals 2x squared plus 5x plus 2. So go ahead and try that one. Pause it here, come back and check. If you did this right, your coefficients are 2, 5, and 2. This would be 4, because it's opposite what it says, so that would be 8, 13, 4 times 13 would be 52, 54, and so you should have had the answer was no. So hopefully you got that one right. And then lastly, show that x minus 6 is a factor of f of x equals x cubed minus 5x squared minus 6x. So, and then factor completely. So again, pause the video, try this one, come back and check. So if you did this right, write down our coefficients. And so that would be 1, negative 5, negative 6. Now in this case there's no constant, so we have to add that 0. So hopefully you did that, otherwise you'll catch your mistake here. Or we're going to do 6, so we get 1, 6, 1, 6, 0, 0. So it works. What we've got left is no constant, but we have, remember this would be x and this would be x squared. So right now we have x minus 6 and then x squared plus x, but we should try and factor that further. In this case, we can pull an x out, and then you get x plus 1. Now you can write it that way, or most of the time what they'll do is bring that x by itself out front. But the order does not have to be in that order as long as you have all those factors. So hopefully this makes sense. You'll find that you just have a lot of different things to look at and make sure you're using whichever method works best for you. So your assignment is page 184, 5 through 49 the odds, and 57 to 63 the odds. So hopefully you found that helpful.